And other than the all other applications like medical medical diagnostic techniques or medical applications, there are another aspect of the magnetic material, and that is used in the memory devices. From stereo cassettes to VCR cassettes, and then CDs, floppies, DVDs, hard disks. So everywhere, magnetic fields are being, magnetic materials are used. Alarm system, doorbells, microphones, speakers. So we are surrounded by the magnetic materials in our daily life. So by making use of the not only the magnetic materials, rather magnetic field applications also another very vast subject. What happened when we apply magnetic materials, magnetic field using different methods? It doesn't necessarily we can apply magnetic field using this magnetic material. Rather, we can apply it by using electromagnet. So, first of all, what happens to the material when it's magnetized? Although it is a long discussion and may not cover completely, in this chapter specifically, this book rather. So, although we know that there is no magnet monopole exists, so magnetic fields are always in the form of north and south pole. Even if you divide a small magnet into thousands magnets, they will become even three magnet each particle, carrying north and south. So it's all about the arrangement of the atoms. When we say that certain material is a magnetic material and certain materials are not magnetic materials, so this is their intrinsic property which come into existence when such materials come into existence. But why would some materials are magnetic and have some magnetic field and they are magnetic materials, and some are not magnetic materials? So what is the reason? Why all materials are not magnetic materials? Because, although all of them have the same electrons, protons, neutrons, such arrangements. So what is the difference between them? What is the difference between magnetic material and non-magnetic material? Why only certain materials have their magnetic field and the rest of them don't have any magnetic field? So their atomic configuration. This is their inherent, naturally, their arrangement of the atoms, which makes them categorized according to their nature. That some material has the tendency to attract iron or other magnetic materials to themselves, toward themselves. Otherwise, they may, as we know, most of them don't have this property, special property. So, so what is magnetic field? Just like electric field, there is a around an electric field, around an electric charge. There is some specific area around which there are field exists which, in which other electron, other charge particle, any charge particle can feel presence of some other charge. So it may be attracted toward the charge or may be repelled by that charge. So there is some similarity between electric field and magnetic field. Electric charge will apply electric force on the charge, depend upon the magnitude of the charges. and also follow the Coulomb's law, which is inverse square law. And but what happened in the case of the magnetic field? Magnetic field case is a little bit different. It doesn't depend upon only the charge magnitude. Rather, it also depends upon its velocity. Because it is observed that there is no force, magnetic force, on a static charge particle. The charge particle is static. It may not observe any presence of any magnetic field. So whenever there is some magnetic field and a charged particle is moving, then it can feel presence of magnetic field. So after observation and experiments, so this equation is designed and which is written in this shape form of the vector product B cos B. So another result is that there must be for the maximum force, maximum deflection, there must be uh, they must be perpendicular to each other because cross product will become the maximum when both vectors have uh, perpendicular to each other. Otherwise, uh, if a particle is moving parallel to the magnetic field, direction of the magnetic field, it may not be able to uh, detect any force, any field. So means in order to determine the resultant force, the resultant direction, final direction of the charged particle, in which direction it will prefer to move, it will be detected, it will be predicted based on this equation and basis on this vector product. And similarly, as we know, whenever there are two cross products of the two vectors, we can apply the right hand rule. So by applying the right hand rule, remember the finger of this, your right hand, uh, will point the direction of the velocity of the charged particle, and palm and vector area coming out of this, your palm will be the direction of the magnetic field. And your thumb straight will show you the deflection. If a charged particle is moving like in this direction and you have applied magnetic direction, next one will be out of this section in upward direction. And what happens in case of positive charge, it will be reversed. Direction will be reversed. So, so basically, this right hand rule is being explained for the conventional charge, and we take it as a positive charge particle, conventional charge. So, if its direction is upward direction, then what will happen in case of electrons? It will be opposite direction. So, in this book and upcoming topics, they will follow this convention that this is basically for positive charge. So positive charge will move in upward direction and negative charge will move in downward direction. So this is how to elaborate the right hand rule in order to determine the direction of the magnetic charged particle in any magnetic field. Its unit is Tesla. The table, look at the table on the left of the screen. Here are some magnetic field of some uh, planets or some. other neutron star have such a huge magnitude of the magnetic field, and other some electromagnetic field, and Earth's surface itself for -4 Tesla. So this magnetic field has extreme importance for life on our planet, on our surface, because this magnetic field protect us from so many radiation, so many things, especially cosmic radiation, which are coming from some produced as a result of some solar interaction, solar activity. So when and there is another very interesting phenomenon which is also not discussed here in this book, a production of aurora boreals, uh, are southern light or northern lights. So if you will go to Google and write there what are the southern light or northern lights or aurora boreals, so you will see some interesting images and some interesting videos will be there, video links, because these are the lights which appear on some near North Pole or South Pole in summer season when skies are clear. Some unexpected light patterns appear on the sky, on the horizon. So which so the reason, one of the reason is that the charged particles are coming from some solar activity. When enters into the Earth's magnetic field, they are slowed down by the Earth's magnetic field. They are deviated from their actual path, and as a result, when they are slowed down, they produce some radiation, and as a result, they make visible to us at large scale. So this is natural phenomena happen on in northern and southern poles of the Earth. So anyhow, you must have solved this problem because we have solved it already in class. This is very important. So every application of magnetic field, this one of the application to become possible is the discovery of the electron. Behind the discovery of the electron, there is the success of the producing magnetic field. When we apply cross field means, here what is meant by cross field? Cross field means we are applying electric and magnetic field in such a way that they cross each other. And what is the what is the result when we apply in such pattern? What happens actually, and why uh, we are doing this thing? So this was basically the discovery of the J.J. Thomson, and this experiment was performed in so many ways. uh, J.J. Thomson experiment. So one of the method is the cathode ray tube method, or discharge tube method, in which basically due to this experiment, the electrons was discovered. Or in other words, you may say J.J. Thomson is the inventor of the discovered the electrons in using this concept. So how did it happen? How he applied the both electric and magnetic field simultaneously, and how they must be applied. And some required all these things required some theoretical work, and then this experimental work. So jointly, this equation, by using both these electric and magnetic field, uh, we are able to measure the specific some specific characteristics, some specific quantities. One of them is charge to mass ratio, which is a very important in different fields of nuclear physics and some other. field where spectroscopy, another material, other fields, material related fields. So how this experiment was performed, actually the important thing is the solution of this equation. If you someone who remember this equation was solved in class, so I think you people must have the solution of this equation. It not will be solved here. So first of all, production of electrons. How electrons can be produced. And Gary Thompson used this filament and very high battery, and then electrons produced from filament will move forward. Then there is a screen in order to convert this scattered electrons into beams. And then electrons will be produced in all directions, and they will move